Good day. You are welcome to our chemistry class. I am Salahuddin Abdulwasiu, and today we'll be looking at naming of compounds. Now, compounds are usually formed when two or more elements come together and they are combined chemically. Now, compounds can be grouped into two. We can classify compounds into two. Now, this is a simple form of a compound. You see, this is a simple example of a compound AB. Now, the A is an atom and the B is also an atom. Now, this compound can be divided into two parts. Now, the first part is the cation. That's A is the cation, while the B is the anion. Now, compounds can be classified into two. We have the binary compounds, just like this one. In binary compounds, we have just two elements forming the compound, element A and B. So this is a binary compound. Now, we also have polyatomic compounds. In polyatomic compounds, we have more than two elements forming the compound. Now, if you look at the example here and here, these two are are polyatomic compounds. ABCY, AXBCY are polyatomic compounds. Now, in the first one, ABC, now, if we are to divide this into two, we'll have something like this, and this becomes the cation, and these two are the These two are the anion. This is the cation here, and this is the anion. Now, the cation here is just an atom, and the anion is a group of atoms. Atoms. So in this case, we have two atoms forming the Forming the anion. So in the first one, you can see that you have no subscript here. This is due to the fact that Bc as an ion does not have a single charge. Example is this hydroxide ion. So Bc in this case is of this type. Now in the second example, you have AXBCY. For the cation, you also have you have a subscript. So this is of the type it means this anion here is of this type, and probably the cation is of maybe this type, aluminium. So the red ones are the anions, and these are the examples of possible anions that you can use to replace all these A's. Then for the anions, we can have them in two types. Now, you have just a single atomic ions here, like your chloride, your fluoride, your bromide, your oxide, and your nitride. Then you have grouped ions. That's grouped ions. So you have like a hydroxide, your trioxynitrate 5, tetraoxosulfate 6, and tetraoxophosphate 5. So these ones here now are of these types, while these ones here are of this B type. So we can actually combine any of these to form to form different types of compounds. So let's pick the first. Let's look at some examples, picking hydrogen ion, and let's pick chloride ion. So in this case, you have positive one and negative one. So because they are equal and opposite, they will cancel out. So you can simply have HCl, and this is your hydrogen chloride. So in naming this, you have you name it as hydrogen chloride, because this ion is named as chloride, but the atom is chlorine. The ion is chloride and the atom is chlorine. So this is hydrogen chloride. So let's pick another example. So in this case now, we can pick let's pick potassium, that's this, and oxygen. So we have K plus and O2, and sorry, let me pick my eraser, and O2 negative. O2 negative. Now in this case, they have what? Equal, they have what? Opposite charge that are not equal. They have opposite charges that are what? That are not equal. So there's what we call what? Exchange of valency. In exchange of valency, what we mean is what? These two on oxygen will be transferred to the potassium here, and the 1 plus 1 on oxygen, on potassium, will be transferred to the what? To the oxygen. So we have something like K2, that's the 2 from oxygen, O1, that's the 1 from potassium. Now, because we have 1 here, you don't need to indicate the 1, so you can simply leave it as this. And this is what? Potassium oxide. Potassium oxide. So let's look at another example. Let's look at another example. So let's pick magnesium and oxygen again. So we have Mg 2 plus and O2 negative. Now the charges are equal and opposite, so you have +2 and -2, so they will cancel out. So you simply have MgO, magnesium oxide. This is magnesium and this is oxygen. So in the ionic form, it is called oxide and not oxygen. So you have magnesium oxide. So let's look at another example. Let's pick calcium, Ca 2 plus, and nitrogen. That's nitride. So for calcium has 2 and nitrogen has 3. So there will be exchange of valency. The 2 on calcium will be transferred to nitrogen, and the 3 on nitrogen will be transferred to what? Calcium. So you have Ca3 N2, and this becomes what? Calcium nitride. Calcium nitride. So now let's look at combination of cations with what? Group ions. With what? Group ions. So let's look at that. Combination of this with what? With group ions. So we can pick any of these are what? Any of these are grouped ions. So let's pick hydrogen, and let's pick nitrate, NO3 minus. Now the charges are equal and opposite, +1 and -1, so they will cancel out. So you simply have HNO3. Now in naming this compound, it will be, you always name from the what? From the anion, from the anionic side. Now the truth is, you are supposed to name from the cationic side, but whenever you have what? Hydrogen, you forget about the hydrogen. Normally this compound should be what? Hydrogen trioxonitrate 5, but because we always take hydrogen to be 1, because it has atomic number 1, so it is the first element in the periodic table, so you forget about the what? The hydrogen, and you name it as what? Tri. This is a tri. This 3 here in chemistry, tri stands for 3, so you have trioxo, that's 3 oxygen, trioxonitrate 5, trioxonitrate 5. Now where is the 5 coming from? The 5 is coming from the what? The oxidation number of nitrogen in this compound, and in our next class we'll look at how to calculate the oxidation number. But there's a simple trick in getting that. Now because nitrogen is in group 5, it will be trioxonitrate 5. So that, though that trick does not always work, sometimes you need to calculate what? The oxidation number. So in our next class we'll look at how to calculate what? Oxidation number. So let's take another example. Let's take sodium plus and SO2, SO4 2 minus. SO4 2 minus. We are picking sodium plus and SO4 2 minus. So in this case now, the 2 on the sulfate SO4 will be transferred to sodium. So we have Na2, and we have 2. We have 1 on sodium. So we have SO4. That will be 4 times 1, that's 4, SO4. So this compound is named as, now in this case, if you look at this compound, we are starting with what? Sodium, not hydrogen. So it will be what? Sodium tetra. Tetra means what? 4. So tetra, sodium, tetra means 4, tetra oxo sulfate 6. The sulfate 6, the 6 is the oxidation number of sulfur, and using my trick, sulfur belongs to the group 6 in the periodic table, so that will be 6. I told you that trick does not always work. It only works mostly for the first 20 elements. So we have what? Sodium tetra oxo sulfate 6. Sodium tetra oxo sulfate 6. So let's take another example. Let's take magnesium 2 plus and PO4 3 minus. Now the 3 on the phosphate ion will be transferred to the magnesium. So we'll have Mg3. Now the 2 on the magnesium will be transferred to the phosphate. So in that case, because we already have a 4, a number here. This is 4, so we cannot add another 3 directly to this. So we put it in brackets, PO4. Then the 2 from magnesium will now come here, and this compound becomes magnesium tetra oxo phosphate 5. Oxidation number of phosphorus is 5 in this compound, and phosphorus belongs to group 5. So you can try for other compounds, and in our next class we'll be looking at how to calculate the oxidation number of elements in different compounds.